Hello, Math 130 students. We are going to go over section 8.7, logarithmic and exponential equations and applications. So here we have our 5 steps for solving log equations. So we're going to try and follow them for number 1. So we want to solve this log. So first step, we want to isolate the log on one side of the equation. Well, here's a log, and they're isolated. So step number 1 is done. Step number 2 is write a sum or difference of logs as a single log. Well, that's already done, so we don't need that. And here, what we want to do is we want to solve this logarithm. So I'm going to take this 2, and I'm going to bring it up on top so that I have log base 7 of 6,561 is equal to log base 7 of x squared. So it's sort of like I'm condensing this, okay? So now from here, what we can do is your property of 1 to 1. So we know that this is log base 7, and this is log base 7. Then the 1 to 1 property tells us that those two things that are highlighted are equal to each other. So I know that 6,561 is equal to an x squared. Well, to undo a square, I have to square root both sides. So I have the square root of 6,561, and that gives me 81. So plus or minus the square root of 81 is equal to x. So this is saying that x is equal to a positive 81, and x is equal to a negative 81. So those are going to be our two answers. So number 2 is very, very similar. So I still have that square. So I'm going to rewrite this as log base 5 of x squared is equal to log base 5 of 169. So now since the logs are isolated on both sides, since it's equal, I can set the insides equal. So x squared is equal to 169. So again, I can square root both sides so that x is equal to plus or minus, and the square root of 169 is a 13. So I have x is equal to a positive 13, and x is equal to a negative 13. And actually, I want to kind of go back a little bit. So I really want to kind of go back on what I just said. I forgot to do number 5, which is to check the solution to verify they're in the domain of my original problem. So make sure to check your solutions that you get. So let's check for x is equal to 13. So I'm going to have 2 log base 5, and what I'm plugging in here is going to be a positive 13. Let's see what that is equal to. We think that it's going to be equal to the same thing as log base 5 of 169. So I'm going to figure this out with the help of my calculator. So I can go to math and go down to your log base. So it's log base 5 of 169, and that's equal to a 3.187. Right? So let's see if that's the same on the opposite side. So I have 2 and it's log base 5 of a positive 13. And it's equal to the same decimal, that 3.187. So I know x is equal to a positive 13. Checks out. That's perfect. Now let's try this for x is equal to a negative 13. So I would have 2 log base 5 is equal to log base 5 of 169. So I already know that log base 5 of 169 is 3.187. And what I'm plugging in now is a negative 13. Let's see if we get the same thing. Well, if I have 2 and I have my log base 5 of a negative 13, it gives me an error. The reason why is because the inside of the log must be positive. So x is equal to negative 13 did not work out. And this is because inside of log must be positive. So because this is true, I did that formal check. I do not believe that this is going to work for number 1, which I have that x is equal to negative 1. Let's just plug that into my calculator and let's just see what we get, right? So let's see what happens when we plug in that negative 81. So if I have 2, and I go to my log base of 7, and here, remember, the answer that we got for x is a negative 81. So the inside of the log is negative. I already know this is not going to work. So it does not work. So again, so please go back to number 1 and realize that because it's negative, it will not work because when you plug it back in, the inside of the log is negative. So that is what it means to make sure that you check in the domain of the original problem. If it does not fit into the original domain, then we exclude that answer. So let's see what happens with number 3. So I have my logs, they're isolated. So I'm going to set the insides equal to each other. So x squared minus 24 is equal to a negative 5x. Well, I'm going to add 5x to both sides to get it equal to 0. So I can have x squared plus 5x minus 24 is equal to 0. From here, I'm going to factor, and I know I'm going to factor because I have a degree 2 polynomial. So if you need to do the AC method, that's fine, where I have my A, my B, and my C. But I know that I want to multiply to a negative 24 and adds up to a positive 5. So 24 is 1 times 24, 2 times 12, 3 times, what is that? 8, and 4 times 6. So the only combination that's going to add up to a positive 5 is 3 and 8. So that is only if I do a positive 8 and a negative 3. So I have x plus 8 and x minus 3. So that tells me that x is equal to a negative 8 and x is equal to a positive 3. So make sure to check your solutions. The first one we're going to check is, let's say x is equal to a negative 8. So we can bring up our calculator. So we have log, and I have x squared. So the value that I'm plugging in is a negative 8 squared minus 24. That's equal to that decimal. So if I do the right hand side, log of parentheses, negative 5 times, and we have here our negative 8, I get the exact same value. So we are good. So we know that x is equal to negative 8 is a good answer. So now let's also check x is equal to a positive 3. Does that also work? Well, if I have my log, and here we're going to have 3 squared, and we have minus 24, I get a negative answer. So x is equal to 3, it makes the inside of the log negative. So, 9 minus 24 is a negative number. Therefore, it's not going to work. So it fails our check. So the only possible answer that we have is x is equal to a negative 8. So you have to be careful with checking our domain, right? Is it going to make the inside of the logarithm negative or positive? So number 4, we have to do more work. The reason we have to do more work is because now we have 2 logs on the same side. It's not isolated anymore. And the reason it's not isolated is because we have a subtraction. So before we can even begin to say, this side is equal to this side, we have to get rid of that subtraction sign. And the only way to do that is to use our quotient property. So remember, when it's subtraction, we can condense our expression into a division. So I know this is really going to be, or maybe I'll just write the property so you guys can see it. If I were to have log of x over y, that's equal to log of x minus my log of y. So now we're going backwards, right? Now we're starting that it's a subtraction, and we want to get to this condensed division. So I know that I have a log, and I'm going to have something in my numerator, something in my denominator, and I have minus log of x. So what do I have? So I have the first thing here, that's going to be my numerator, so I have my x plus 4. And I also have my denominator, which is here, which is that 5x plus 12. So now I have that log of x plus 4 over 5x plus 12 is equal to a, and here I see that negative floating around. So I'm going to make that go to my numerator. And you can think of it as a negative 1 if you want. So it's going to be log x to the negative 1 power. Okay. So now I can set the insides equal to each other. So this inside is equal to this inside, since they're both logs. So I have an x plus 4 over 5x plus 12 is equal to an x to the minus 1 power. So what I would do from here is make sure that I use my rules of exponents. And knowing that x to the negative 1 is really 1 over x. So I'm going to go ahead and do that over here. So I have x plus 4 over 5x plus 12 is equal to 1 over x. Now, on the next step, I'm going to cross multiply. When I cross multiply, I'm going to have x times my x plus 4 is equal to, and now the opposite side is going to get multiplied, so 1 times my 5x plus 12. So I can get x squared plus 4x is equal to a 5x plus 12. So now what I want to do is I want to get this equal to 0, so minus 5x minus 12. And so when I do that, I'm going to have an x squared, and 4 minus 5 gives me a negative 1x minus 12 is equal to 0. From here, I'm going to factor. You can use the AC method, or you can use guess and check. Here, if I have 12, I'm going to get a 3 and a 4. And it would be a negative 4 and a positive 3 to add it to a negative 1 and multiply to a negative 12. So I have x is equal to a negative 3 and x is equal to a positive 4. But remember, don't forget to check your solutions. So I'm going to go ahead and plug this into my calculator. So let's think about this. We are going to check for x is equal to negative 3. Well, just by clicking or checking here for our negative log of x, let's see what happens when I plug in that negative value. So minus log, and here that x value is negative 3. I get non-real answer. So I already know that this answer cannot be so. So now let's try it for x is equal to a positive 4. So I'm going to have minus log of a positive 4, and I get that decimal. So perfect, so let's try it. So log of, and I have 4 plus 4 minus my log of 5 times 4 plus 12. Does that equal to the same decimal? And it does. So notice how the line above and the first line and the second line are the same. So x equal to 4 definitely works. So you can just check on your calculator. And we see that x is equal to 4 is the only answer that's going to work. And we checked to make sure that it satisfies the domain of our equation. For number 5, it's slightly different. But what you want to look at is the base. So here I have my base equal to 4. Is there any way to get 64 as a base of 4? Well, let's think about it. If I have 4 squared, that's equal to 16. 4 to the third power, so 4 times 4 times 4, that's equal to 64. So I can use this to rewrite that 64. So now I'm going to have 4 to the 2x minus 9 is equal to, and since I already know it's equal to 64, that 64 is equal to 4 to the third, I'm going to rewrite it as 4 to the third power. So now I can say that these exponents are going to be equal to each other. So 2x minus 9 is equal to a positive 3. So I'm going to add 9 to both sides. So that 2x is equal to 3 plus 9, which is my 12. So if I divide both sides by 2, I get that my x is equal to 6. And if we check it, we are checking that 4, 2, and then here that 2 is being multiplied by 6, minus 9 is equal to that 64 value. So does 4 to the power of 2 times 6 minus 9, does that equal to a 64? It does. So I know that x is equal to 6 is a good answer, and I have already checked it, so that's what my final answer is going to be. Now, we want to solve our exponential equations using logarithms. So here, I want to isolate the e, so I'm going to divide by 6 on both sides. So that e to the 2x is equal to 24 divided by 6, which is equal to 4. Now, because this is what I have, I can cancel out e with natural log. So I'm going to natural log both sides. That way the natural log and the e cancel, so I'm left with 2x is equal to the natural log of 4. From here, I can divide by 2 on both sides, so that x is equal to a natural log of 4 divided by 2. So now I definitely want to bring up my calculator and plug this in. So I have my fraction, and I have my ln of 4, that's inside the parentheses, divided by 2. When I plug that in, I get my decimal approximation of 0.69314. And since it's specifically asking me to round to the 3 decimal places, then the third decimal place here is 3. So I take 1, and it's going to tell me how to represent. So I'm going to get that x is equal to a 0.693 because of how we round. Okay. Now let's look at number 2. It's the same process. So since it's being multiplied by a 1/4, I can multiply by the reciprocal, which is just a 4. That way I have e to the 2x is equal to 12. Now I can ln both sides. So the ln and e cancel, so I'm left with 2x is equal to the ln of 12. And again, I'm going to be dividing by 2, so that x is equal to the fraction of ln of 12 divided by 2. And so now it becomes a calculator problem. So I have my fraction of a ln of 12 being divided by 2. And I'm going to go ahead and copy that down. So I copied it down, and I'm rounding to 3 decimal places. So that 4 tells us to leave that 2 alone, so that x is equal to 1.242 as your final answer. Number 3 is going to be about more or less the same process. So I'm going to divide everything here by 4, so that e to the x minus 7 is equal to, and if I have 84 divided by 4, I have a positive 21. To get rid of e, I'm going to ln both sides, so that ln and e cancel. So x minus 7 is equal to the ln of 21. And here, I'm going to add 7. So that I have x is equal to the ln plus 7. And it tells us to round to the 3 decimal places. So I'm going to have my ln of 2 plus 7. I'm going to go ahead and copy that down. So I'm rounding to the 3 decimal places. That would be the 3. The 1 tells us to leave it alone, so that x is going to be equal to that 7.693 as my final answer.